Hi students, how are you? Stay home, stay safe. In this class, we are learning method of mixtures. Let us discuss the principle of the method of mixture. The method of mixture is also known as principle of calorimetry. This is also known as the principle of calorimetry. What is mean by calorimetry? Here, the calorimetry is the study of transfer of heat, right? Okay, fine. Suppose we have two types of liquids and one is hotter than the other. One is said to be hotter body, that means a hotter liquid, right? Another is colder liquid, right? Now we mixed these two liquids. After mixing, the temperature of the mixture will be different than the liquids. It happens because hot liquid releases the heat and cold liquid gains this heat. Now there is no loss of heat, then heat lost by hot body will be equal to the heat gained by a cold liquid. And this is called as a principle of method of mixtures. Already we know the heat is a form of energy. Hence, this principle is based on the law of conservation of energy. Hence, this principle is based on the law of conservation of energy. Now, to understand it more clearly, let us take some situations. Situation 1. In this situation, we take two beakers of the same size and pour 200 ml of water in each of the beakers. Now, heat the water in both the beakers till they attain the same temperature. Now take a large beaker and pour this water from these two beakers into a large beaker what we have taken. But dear students, can you guess the temperature of this mixture in a large beaker? What do we observe here? Obviously, we can observe here that there is no change in the temperature of the mixture. That means the temperature of the water in both the beakers before mixing is equal to the temperature of the mixture in a large beaker. Because there is no transfer of heat energy. It happens when both the liquids have same temperature, their mixture also have same temperature, right? Okay, fine. Take one more situation. In this situation, take two beakers of same size and pour 200 ml of water in each beaker. Now, heat the water in one beaker up to 90 degrees Celsius and other to 60 degrees Celsius. Now mix the water from these two beakers in a large beaker. Dear students, what will the temperature of mixture be? After mixing, the temperature of a mixture will be different than the temperature of the water in beakers. When we measure the temperature of the mixture of the mixture by using thermometer, it shows us 75 degrees Celsius. What is the reason? Here we consider 90 degrees Celsius of water is hotter than 60 degrees Celsius of water. Means 60 degrees Celsius of water is colder. So it happens. Hot water releases the heat and cold water gains this heat. Right. Now situation 3. Take two beakers, right? Now take 100 ml of water at 90 degrees Celsius in one beaker. It is labeled A, and 200 ml of water at 60 degrees Celsius in other beaker labeled B. Now take a large beaker and mix the water from these two beakers in a large beaker, right? Now here we got one question. What is the temperature of the mixture? Let us find out. Let the initial temperature of the water in beaker A is T1, that is at 90 degrees Celsius, and the initial temperature of the water in beaker B is T2, that is at 60 degrees Celsius. Now let the mass of the water in a beaker A is M1 and the mass of the water in beaker B is M2. Here T1 is higher temperature because it is 90 degrees Celsius. T2 is lower temperature, that is 60 degrees Celsius. Let T be the final temperature of the mixture. Here we have observed that the temperature of the mixture is lower than the temperature of the hotter sample, but higher than the temperature of the colder sample. This means that the hotter sample has lost its heat and the cold sample has gained heat. So the amount of heat lost by the hotter sample, that is Q equal to M1 S T1 minus T. Here T1 minus T means change in temperature delta T, right? So Q1 equal to M1 S T1 minus T, where T1 is greater than T. T1 is greater than T means the initial temperature of the water is greater than the final temperature of the mixture. So we can write T1 minus T instead of delta T, right? Next, the amount of heat gained by the cooler sample, that is Q2. Q2 equal to M2S T minus T2, right? Q2 is equal to M2S T minus T2. Why do we write T minus T2? Because T is final temperature. It is greater than initial temperature of the cooler water, right? Cooler sample. So we can write T minus T2 because T is greater than T2. Since heat lost by the hotter sample is equal to the heat gained by the cooler sample. Here one condition is there. If there is no loss of heat in another process, right? That means Q1 equal to Q2. Now we have to substitute all these values, Q1 values and Q2 values. So Q1, that is M1S T1 minus T, that equal to M2S in bracket T minus T2. By simplifying, M1S T1 minus M1S T, that is equal to M2 ST minus M2S T2. By simplifying, we get T equal to final temperature T equal to M1 T1 plus M2 T2 by M1 plus M2. This is the formula for final temperature, right? So whenever we have to find the final temperature of the any mixture, we have to substitute all these values of mass, initial temperature, final temperature, right, etc. Like this, we can find the final temperature of any mixture. Once again I revise. We mix any two liquids of different temperatures, then we get the intermediate temperature of the mixture. If there is no loss of heat, then heat lost by hot body will be equal to the heat gained by a cold body. This is the principle of the method of mixtures. I hope you have understood.